This is a video on section 11.4 related to the cross product. But I mean by the cross product, I mean the cross product of vectors. So this continues our sequence of ideas related to operations on vectors. So you'll recall that in the previous video we've had two vectors v and w, and we computed their dot product of these two vectors, and this returns a number. Okay, and we had formulas for the dot product. Was given by the magnitude of v, magnitude of w, cosine of the angle between them. So these were our interpretations, and we also showed that when v dotted with w was equal to 0, this implied that the vectors v and w were perpendicular to each other. Okay, so as regards the cross product, it's an operation on vectors. Okay, so you first must be given two vectors in 3 dimensions. Okay, now let me just say that, let's say our vectors are A, let's say it's A1, A2, and A3. We've got a vector A, we've got a vector B. This could be any numbers, B1, B2, B3, or A1, A2, A3. So these are just two general vectors. Okay, it means they can be anything you want for A, B, for the A's and B's. Okay, our goal, okay, for this section is to find a vector C that is perpendicular to both the vectors A and the vector B. Okay? So using our knowledge of the dot product, we can formulate this question. Okay? So for example, maybe here's your vector A, here's a vector B. Okay? Our goal is to find a vector C here that is perpendicular to both A and B. Okay, so what is this vector? Okay, well, we know how to formulate the question. You can formulate this question, the question of finding a vector C that's perpendicular to both A and B. We can formulate this question as some equations to solve. The equations to solve are that you want to find the dot product of A with this vector C. If C is in fact perpendicular to A, the dot product better come out to be 0. This vector C also needs to be perpendicular to the vector B, so that must also be 0. Okay, and here are some equations that we would like to solve. Okay, so I will go over here to Mathematica and show us how to accomplish the solving of these equations. All right, this solving of these equations will lead us to, if we can solve this, this will lead us to the vector C. And we'll fill in the blank here. The vector C is going to be some vector also in R3. And we then need to figure out what goes here, here, and here. So we're going to go over here to Mathematica and try to see if we can develop a formula for this. Okay, so I will define two vectors, A1, A2, A3. Here's the first vector A, and it has 3 entries, A1, A2, and A3. I'll define a vector B. It'll be B1, B2, B3. First, second, and third entries of the vector B. And I'll define a vector C, and we won't know what this vector C is, so let's say that A and B vectors are given. So what I mean by that is you know A1, A2, A3, B1, B2, and B3 are all known. Okay. What's unknown, C1, C2, and C3 are unknown. Okay, and it's our job to find C1, C2, and C3. So what we need to do, we need to take the dot product of A with C. and that's supposed to come out to be 0, right? A dotted with C would be A1 C1 plus A2 C2 plus A3 C3. Set that equal to 0, and there is the computer doing the dot product for you. There's your first equation. We'll call this equation 1. Okay. The second equation, equation 2, is B dotted with C. That's also supposed to equal 0. So there is your second equation. Okay. And what we want to do now is to solve both equation 1 and equation 2. Now we know something weird's going to come out here. Solve both equation 1 and equation 2 for C1, C2, C3. If you're counting, you know that something should be a little bit weird here because we have two equations, right? But we have 3 unknowns. Okay. So no matter that little problem, let's see what happens if we ask the computer to solve equation 1 and equation 2, and we want to solve it for C1, C2, and C3. Okay. So the computer, it knows that something weird is going on. It's saying not all solutions may be given, but here's a solution that it says. Okay. Now, let's see. So here we have a solution over here. Right here from the computer here, we can see that C1 can be anything that we would like it to be. That's what is showing here. It's saying C2 and C3 are solved in terms of C1. So we can let C1 be whatever we want it to be. And if you let C1 equal just the denominator here with a minus sign, let C1 equal to A2 B3 minus A3 B2. If you let C1 equal that, because you can choose it C1 to be whatever you want, then C2 comes out to be A1B3. I'm worried about minus signs here, but A1B3 with a minus sign plus A3B1. And then C3 will come out to be A1B2 minus A2B1. Okay. Now so here my claim is that if you let C1, C2, and C3 be these entries, let those fill in the blanks over here, okay, you will have your vector that is perpendicular to both A and to B. Okay, let me take a moment here to just double check my minus signs. I will be back in just 1 second. Okay, I'm back. These signs for C1 and C2 and C3 do work. So let me show an example of how this is working. So for example, if A is the vector, say 1, 2, 3, so we know that A1 is 1, A2 is 2, and A3 is 3. And let's let B equal to 1, 0, 1. Okay. Then I'll say that B1 is 1, B2 is 0, and B3 is 1. Okay. Now where does this vector C come from? C is C1, C2, C3, where you get to use these numbers over here. So C1 comes out to be A2, which is 2, B3, which is 1, minus A3, which is 3, B2 is equal to 0. C2 comes out to be minus A1, minus 1. B3 is equal to 1, plus A3 is equal to 3. and then B1 is equal to 1, and then C3 comes out to be A1, which is 1, B2, which is 0, minus A2 is 2, B1 is equal to 1. So this tells us that the vector C should come out to be 2, negative 1 plus 3 is 2, and then negative 2. Okay, so if we have the vector A, which is 1, 2, 3, and B is equal to 1, 0, 1, we've created a new vector C from A and B that is 2, 2, negative 2. Okay, we should probably check that. Is it true? You should check that we have accomplished our goal. Is A dotted with C equal to 0, and is B dotted with C equal to 0? A dotted with C will give you 2 plus 2 minus 6. And so A dotted with C. 2 plus 4. Sorry, 2 times 2 is 4. Minus 3 times 2. That does in fact give you 0. Okay. B dotted with C. B dotted with C would give you 2 plus 0 minus 2, which is 0. Okay. So we have shown that using the formula that we have, that if you are given a vector A and B, that you can find a vector C that is perpendicular to both A and B. Okay, so what we've just done in a picture here is that, again, A and B were given, whatever they look like, and we have now found a vector C, okay, that is perpendicular to both A and B. Okay. This formula is rather a challenging one to memorize because of these weird minus signs that are present in the formula. And so I would like to show you now a way to compute this vector C with a helpful memory device to remember how to compute the formula. Okay, so let me go to the next page here. So remember that we've got A and B are given, okay, and the goal is to find a vector C perpendicular to A and to B. Okay. This vector, since C, on our previous formula over here, since C, the formula for C, notice that C here, like C1, notice that it has only A's and B's in it. C2 has only A's and B's. C3 has only A's and B's in it. That says that the vector C you're obtaining from the vectors A and B. So the conclusion you can draw, we can give C a better name. We can name C. Okay, we'll give C a name, and we're going to call it A cross B. Okay, this stands for C. The vector you get is called the cross product of A and B. Cross product of A and B. So A cross B is a new vector that is perpendicular to both A and B. The formula for A cross B, we saw it on the previous page, but there is a useful device for how to remember this. You compute these boxes. This will be the E1, E2, E3 entry. Okay. The first entry of the vector A is A1. The second entry is A2. The third entry of the vector A is A3. The first entry of the vector B is B1. Second entry B2, B3. Okay. And our goal is to create the vector that has these three entries. Okay. What goes in the first entry is to, this is the some number times E1 plus some number times E2 plus some number times E3. That's one way to write it. Or you could write it as some number times I plus some number times J plus some number times K. Just depending on how you want to write these, the goal is still the same, that you are trying to fill in, okay, these 3 entries. Okay, so pick your favorite notation. Okay, but the formula for it to fill in the first entry, okay, whichever way you want to write it, you go to the mark out the first row and the first column of this determinant matrix, it's called, and then you're going to look at this block and you're going to compute A2 multiplied by B3, and then on the off diagonal you're going to subtract. So the first entry of the cross product is equal to A2B3 minus A3B2. Okay. Comma. Now we need to go to the second entry. In the second entry, you just go ahead and put a minus sign here, just because that's the way the minus signs have to work out. But I just go ahead and on the second entry of the vector, I just put a artificial minus sign, and we go to here and we mark out the row that has the column and row that has the E2. Okay. And therefore the numbers that you're going to be looking at are A1, A3, B1, and B3. And I'm going to multiply them in the same way. I will get A1B3 minus A3B1. Okay. And we'll go to the last entry now. Okay. The last entry of the vector, I'm going to mark out the last vector E3, and then the numbers I'm going to be looking at are the A1, the A2, the B1, and the B2 for this last entry. And you'll multiply in the same way, A1, B2 minus A2, B1. Okay. And this leads you to the same result that we had on the previous page. Same result as on the previous page. Okay. So let me do an example with this, with actual numbers for this cross product, okay, operation. Okay, let's say that the vector A is 3, 1, 0, and the vector B is equal to 1, 2, negative 1. Okay, the vector A cross B. Okay, this is a new vector. And my claim is supposed to be perpendicular to both A and B. Okay, how do you get it? You need to fill in the 3 entries of this vector. Okay, where do those 3 entries come from? The easy way to compute them is to set up this determinant I, J, and K instead of E1, E2 if you wish. I'm trying to use 2 different notations for those that like either one. The I, J, K entry of the vector. Here's the I entry of the vector, the J entry, and the K entry. The vector A would be 3, 1, 0. The vector B is 1, 2, negative 1. And I'm going to knock out the first row and first column, and that leaves this block here. So it's going to be 1 times negative 1 plus 0 times 2. That's the first entry of the vector. Okay. The second entry of the vector, okay, you knock out the J entry, put an artificial minus sign. Just needs to be there to make the result work. The numbers you're looking at are 3, 0, 1, and negative 1. So you'll get 3 times negative 1 minus 0 times 1. And then the last entry of the vector will knock out this row and this column, and the numbers you're focusing on are these. So you'll get 3 times 2 minus 1 times 1. And the answer you get is negative 1, negative 3, 0 times 1 is 0, and then you'll get 6 minus 1. So the answer you'll get is negative 1, 3, positive 5. Okay. So here's the answer we're supposed to get for our vector C. Instead of calling it C, we call it A cross B because it's a vector that comes from the vectors A and B. So we should double check that. We have A is 3, 1, 0. We have B, which is 1, 2, negative 1. And we have C, which is, or A cross B, our vector A cross B is negative 1, 3, 5. You should double check that A dotted with A cross B, is that in fact 0? You should check that B dotted with A cross B is 0. Is that true? A dotted with A cross B is going to give negative 3 plus 3 plus 0, which does come in fact out to be 0. B with A cross B, you'll get negative 1 plus 6 minus 5, which does come in fact out to be 0. So this was a quick video just on where the notion of the cross product comes in, and we can say that in summary that the vectors A cross B, okay, can be computed from this particular mnemonic, set up this matrix and compute the determinant. So the I entry of the vector A cross B is A1 B3 minus A3 B1. The second entry of the vector is an artificial minus sign. It will be A1 B3 minus A3 B1. And then the k entry of the vector is going to be A1 B2 minus A2 B1. Okay. In the next video, we will discuss the geometric interpretation for the cross product. Let me just show one more thing here on the computer, though, that if you would like to compute a cross product, let's say that you have your vector A is 1, 2, 3, and your vector B is equal to, B is equal to 2, negative 1, 0. You can compute the cross product of those by just saying cross A with B. And there is your answer for the cross product. Okay. Alright, so in the next video we're going to discuss the geometric meaning of the cross product.